Chapter 1. Chemical reactions and equations. Consider the situations like grapes getting fermented, food is getting cooked. Food gets digested in our body. Respiration. In all these situations, the nature and the identity of the initial substance have somewhat changed. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what is actually meant by a chemical reaction. Let us perform some activities to find the answer to these questions. Consider the situations like grapes getting fermented, food is getting cooked. Food gets digested in our body. Respiration. In all these situations, the nature and the identity of the initial substance have somewhat changed. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what is actually meant by a chemical reaction. Let us perform some activities to find the answer to these questions. Clean a magnesium ribbon about 2 cm long by rubbing it with sandpaper. Hold it with a pair of tongs. Burn it using a spirit lamp or burner and collect the ash so formed in a watch glass. What do you observe? Magnesium ribbon burns with a dazzling white flame and changes into a white powder. It is formed due to the reaction between magnesium and oxygen present in the air. Let's conduct one more activity. Take a few zinc granules in a test tube. Add dilute sulfuric acid to this. Do you observe anything happening around the zinc granules? Touch the conical flask or test tube. Is there any change in its temperature? The colorless gas is liberated. Zinc powder disappears and colorless solution is obtained. From these two activities, we can say that any of the following observations helps us to determine whether a chemical reaction has taken place. Change in state, change in color, evolution of a gas, change in temperature. Chemical equations. We have seen activity where a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write it in the form of a word equation. The word equation for the above reaction would be magnesium plus oxygen gives magnesium oxide. The substances that undergo chemical change in the reaction, magnesium and oxygen, are the reactants. The new substance, magnesium oxide, formed during the reaction, is the product. A word equation shows change of reactants to products through an arrow placed between them. The reactants are written on the left-hand side LHS with a plus sign between them. Similarly, products are written on the right-hand side RHS. The arrowhead points towards the products and shows the direction of the reaction. Writing a chemical equation. Is there any other shorter way for representing chemical equations? Yes. Chemical equations can be made more concise and useful if we use chemical formulae instead of words. A chemical equation represents a chemical reaction. If you recall formulae of magnesium, oxygen and magnesium oxide, the above word equation can be written like this. Count and compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms of each element the same on both the sides? If not, then the equation is unbalanced. Balanced chemical equations. Mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. Hence, we need to balance a skeletal chemical equation. Let us learn about balancing a chemical equation step by step. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen. This word equation may be represented by the following chemical equation. Let us examine the number of atoms of different elements on both sides of the arrow. Zinc has 1 atom in LHS and 1 atom in RHS. Hydrogen has 2 atoms in LHS and 2 atoms in RHS. Only 1 atom of sulfur is there in both LHS and RHS, 4 atoms of oxygen are there in both LHS and RHS. As the number of atoms of each element is the same on both sides of the arrow, is a balanced chemical equation. Let us try to balance the chemical equation. Step 1. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Step 2. List the number of atoms of different elements present in the unbalanced equation. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4 and the element oxygen in it. There are 4 oxygen atoms on the RHS and only 1 on the LHS. To balance the oxygen atoms. To equalize the number of atoms, it must be remembered that we cannot alter the formulae of the compounds or elements involved in the reactions. For example, to balance oxygen atoms we can put coefficient 4 as 4H2O and not H2O4 or H2O. Now the partly balanced equation becomes. Step 4. Ferrous and hydrogen atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 on the RHS. The equation would look like this. Step 5. Examine this equation and pick up the third element which is not balanced. You will find that only one element is left to be balanced, that is, iron. To equalize ferrous, we take 3 atoms of ferrous on the LHS. Step 6. Finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the equation. The numbers of atoms of elements on both sides of are equal. This equation is now balanced. This method of balancing chemical equations is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Step 7. Writing symbols of physical states. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formulae. The gaseous, liquid, aqueous and solid states of reactants and products are represented by the notations G, L, Aq, and S, respectively. The word aqueous is written if the reactant or product is present as a solution in water. The balanced equation becomes. Note that the symbol G is used with H2O to indicate that in this reaction water is used in the form of steam. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions, such as temperature, pressure, catalyst, etc., for the reaction are indicated above and or below the arrow in the equation. For example, in the corresponding equation, 340 atmospheric pressure is a necessarily condition. In the photosynthetic equation, terms sunlight and chlorophyll are written above and below the arrow. Types of chemical reactions. The transformation of a chemical substance into another chemical substance is known as a chemical reaction. Chemical reaction can be classified into combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction reaction, combination reaction. Reactions in which 2 or more reactants are combined to form a single product is called combination reaction. General representation of combination reactions can be written as A plus B gives AB. For example, calcium oxide reacts vigorously with water to produce slaked lime, that is calcium hydroxide, releasing a large amount of heat. The reaction can be written as calcium oxide plus water gives calcium hydroxide. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Let us discuss some more examples of combination reactions. Burning of coal. Carbon and oxygen forms carbon dioxide. Formation of water. 2 molecules of hydrogen and oxygen together forms H2O, that is water. In the reaction of calcium oxide, we have observed that a large amount of heat is evolved. This makes the reaction mixture warm. Reactions in which heat is released along with the formation of products are called exothermic chemical reactions. We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. For example, rice, potatoes and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. Decomposition reaction. Take about 2 gram ferrous sulfate crystals in a dry boiling tube. Note the color of the ferrous sulfate crystals. Heat the boiling tube over the flame of a burner. Observe the color of the crystals after heating. Have you noticed that the green color of the ferrous sulfate crystals has changed? You can also smell the characteristic odor of burning sulfur. In this reaction you can observe that a single reactant breaks down to give simpler products. This is a decomposition reaction. Ferrous sulfate crystals lose water when heated and the color of the crystals changes. It then decomposes to ferric oxide, sulfur dioxide and sulfur trioxide. Ferric oxide is a solid, while sulfur dioxide and sulfur trioxide are gases. What will happen to silver chloride if it is placed in sunlight for longer duration? You will see that white silver chloride turns gray in sunlight. This is due to the decomposition of silver chloride into silver and chlorine by light. We have seen that the decomposition reactions require energy either in the form of heat, light or electricity for breaking down the reactants. Reactions in which energy is absorbed are known as endothermic reactions. Displacement reaction. Reactions in which atoms and ions move from one compound to other to form new compound is called as displacement reaction. This can be generally represented as A plus BC gives AC plus B. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 ml copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep 1 iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of copper sulfate solutions in test tubes A and B. Also, compare the color of the iron nails dipped in the copper sulfate solution with the one kept aside. The iron nail become brownish in color and the blue color of copper sulfate solution fades. The following chemical reaction takes place in this activity. Iron plus copper sulfate gives ferrous sulfate plus copper. In this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. Double displacement reaction. Take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride solution. Mix the two solutions. What do you observe? You will observe that a white substance, which is insoluble in water, is formed. This insoluble substance formed is known as a precipitate. Any reaction that produces a precipitate can be called a precipitation reaction. Aqueous sodium sulfate plus aqueous barium chloride gives solid barium sulfate plus aqueous sodium chloride. The white precipitate of barium sulfate is formed by the reaction of SO4 and Ba2+. The other product formed is sodium chloride, which remains in the solution. Such reactions in which there is an exchange of ions between the reactants are called double displacement reactions. Oxidation and reduction. Heat a china dish containing about 1 gram copper powder. What do you observe? The surface of copper powder becomes coated with black copper 2 oxide. Why has this black substance formed? This is because oxygen is added to copper and copper oxide is formed. If hydrogen gas is passed over this heated material, that is copper oxide, the black coating on the surface turns brown as the reverse reaction takes place and copper is obtained. If a substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. During this reaction, the copper oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. In other words, one reactant gets oxidized while the other gets reduced during a reaction. Such reactions are called oxidation-reduction reactions or redox reactions. Have you observed the effects of oxidation reactions in everyday life? First, corrosion. You must have observed that iron articles are shiny when new, but get coated with a reddish-brown powder when left for some time. This process is commonly known as rusting of iron. Some other metals also get tarnished in this manner. When a metal is attacked by substances around it such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships and to all objects made of metals, especially those of iron. Corrosion of iron is a serious problem. Rancidity. Have you ever tasted or smelled the fat, oil-containing food materials left for a long time? When fats and oils are oxidized, they become rancid and their smell and taste change. Usually substances which prevent oxidation, antioxidants, are added to foods containing fats and oil. Keeping food in airtight containers helps to slow down oxidation.